Okay, welcome back. So we'll continue from where we left. So far in if you remember from the previous video, just before this one, we were looking at how to predict the leachate quality, leachate quantity, how to predict the leachate quantity, and how to collect this leachate. So now once you have collected the leachate, what are the basic design elements for leachate collection system? We looked into that. Now once you have collected the leachate, I said that you have to treat it, so and you have to transport it as well. So we'll talk about those aspects and then we'll carry on further. So in terms of leachate, we have to treat this leachate. Now how to do it? Many times what there is you have on-site wastewater treatment plant. You can have, if it's a huge landfill, if it's a big landfill, you produce enough quantity of leachate. So you may see that some of these landfill has on-site wastewater treatment plant. So this treatment plant is used to treat the leachate, and then the effluent is discharged to a surface water, and the effluent has to meet the effluent quality standard. So that's there. Other thing is that if you can haul it to the publicly owned treatment works. So POTW stands for publicly owned treatment works. Basically it's a city level wastewater treatment plant or a regional wastewater treatment plant which is treating the sewage coming up from the city, from the municipal area. So it's like a typical sewage treatment plant, but you are mixing your leachate to it as well, and then you make it a wastewater like a leachate treatment plus sewage treatment plant. And for this you can some cases for this, or you may have to do some pre-treatment on site, because if you think about leachate, it's a nasty thing. It's with the sewage that you and I flush down the toilet is mostly a lot of organic matter these days, maybe some pharmaceuticals and other things going into there, and we're not treating for pharmaceuticals anyway at the sewage treatment plant, but it's mostly organics and other stuff is there, and not much heavy metals and other things will show up in a sewage. Even traces might be over there. But if you think about the leachate with all the different types of waste being disposed into the landfill, the leachate quality will be much different than typical sewage. So you may have to, when you mix them together, you may disturb the microbial population at a sewage treatment plant. So you may have to do some sort of pre-treatment upfront, and then you mix it to a wastewater treatment plant. So you may do some pre-treatment on site. That's what I'm talking about. You do some pre-treatment on site, and then you haul it off site at a publicly owned treatment works. You can use pipeline to do that. You can also have some evaporation stuff in there, and there is a provision of doing a leachate recirculation as well. Leachate recirculation is essentially what it does. It helps into waste degradation much faster. As we have talked earlier, that when you have this waste in a dry tomb condition, because what is this landfill? Landfill is essentially you can think about, I have said that many times, this landfill you can think about as a huge polythene bag. So this this is now a huge polythene bag here, and you put this garbage, you put lots of garbage in this polythene bag, and so part of it will be moist, part of it will be dry. So the dry pockets may not degrade that much because the microbes don't like the dry area. So to make this dry pockets wet, what you come up with this leachate recirculation system, where you start putting some of this leachate back into the system, and that helps in leachate treatment as well, because leachate goes through the garbage acts as a filter, and then over time it becomes more some of the heavy metals and other things will be filtered out inside the landfill. Ammonia gets built up. In the leachate recirculation system, in a bioreactor landfill, your leachate, in terms of the leachate quality, ammonia is one thing which really builds up, but other than ammonia, most of these things actually gets treated because of leachate recirculation. And it also helps in terms of waste degradation, and reduces the cost of leachate treatment, at least for the first several years when you are doing the leachate recirculation. You cannot do leachate recirculation forever. At some point of time, when the waste has degraded enough, there is no more, the quantity of gas production is very low. That means the waste doesn't have any more potential for biodegradation. You need to stop leachate recirculation, and then you have to collect those leachate volume and treat them. But those leachate is slightly matured leachate, a little bit better to treat. You can use mostly different treatment technique, and we'll talk about that in a minute. So, leachate treatment method, you can have aerobic, anaerobic. Again, if you have taken a wastewater course, same thing you talk about in the wastewater course as well. You have activated sludge process. These are the aerobic treatment. You have you have this activated sludge process. As you can see over here, you have this activated sludge process. You have this activated sludge, aeration ponds, equation batch reactor. So, this is what you do for leachate, like a wastewater treatment as well. If you have anaerobic, you can do anaerobic digestion. You can go for anaerobic digestion. You can go for upflow anaerobic sludge blanket, which is the UASB. Upflow anaerobic sludge blanket is also used. So, that's the UASB, which can be used as well. And this is how the leachate looks like. You can see this nasty color leachate which was coming out from this landfill. So, you see those here. It's based on the level of the based on the level of the leachate in this tank, the pumps will kick in and the pump will pump out this leachate to the leachate like a treatment system. So, it will be piped to the next treatment unit. Lined leachate lagoons are also used, where you have this lined leachate lagoon and then you put the leachate in here, let it evaporate, and this evaporates, and you have more concentrated leachate to worry about now. So, moisture, some of the moisture is so you have a concentrated leachate to deal with. So, another picture of the lined leachate, there is places where aeration is also done. So, you aerate it. This aeration breaks down the organic matter as well, because of the aerobic reaction will take place. So, those things do as well. So, here another picture of like a leachate treatment plant. This is in Chile, where I think I showed you that particular like a transfer station where those silos were there. If you remember from a very big from the very beginning, one of the videos in the collection system, where we had those silos taken off and put it on the railway and taken out to the landfill site. This particular leachate treatment plant is for that particular landfill in Chile. So, you have this leachate where you have this brine evaporation. So, you have this evaporation pond. You have some treatment system going on. There is a leachate storage lagoon, anaerobic treatment, anaerobic lagoon, aerobic lagoon. Anaerobic means you just put it like that. You are not doing any aeration. In the aerobic, you can see aeration going on. You can see lots of fog, lots of foams and other things. That white stuff that you see on this particular area, that's because of the air being circulated into the system. So, combination of anaerobic and aerobic, as we do for wastewater treatment plant as well, because some of these organic material, they are easy to be degraded with anaerobic bacteria, and some are easy to be degraded with aerobic group of bacteria. So, we use like an anaerobic and aerobic combination to break down these organic matters, and and then you can also have some sort of like a nanofiltration, reverse osmosis. If you want to make it a very clean water, you can also go up to reverse osmosis too. So, that's but it's costly affairs, but people do that as well. So, here you see the aerobic treatment lagoon, one more close picture of that. And as you can see in this close picture of aerobic treatment lagoon, you see lots of because of the aerations, you see all those white forms because of the aeration going on, and so that is used as in many like very similar you will see in a wastewater treatment plant as well. Then leachate is also treated using wetland. So, you can have the leachate pass through the wetland. So, it acts as the wetland does treat leachate over time. So, it's many times you can have a natural wetland or you can have a constructed wetland. So, use of constructed wetland for leachate treatment is very popular. It's also use of constructed wetland for wastewater treatment is also very popular. But the problem with I would not say problem, that the requirement for this kind of system is that you require huge area. In a place like India, it may not be possible if because I don't know, we may have some areas where we can use it for, but okay, like a wetlands does require a lot of area. This constructed wetlands requires area, but it's a good treatment system as well, where this treatment is done over time. So, then we have this, we can have some aeration pond. We can have some aeration pond, we can have other kind of systems. Here this is a landfill bioreactor system, which is there is a leachate recirculation system, and from the leachate recirculation, once the leachate is taken out, you don't have to worry too much about this sketch over here, although we'll provide you in the as part of the reading material. You can look at it. I'm sure you cannot see it very clearly from this particular video right now because of this small boxes, but essentially what they have is this is a existing bioreactor landfill. This is the sketch for a landfill in Florida. This was a project that I worked on almost 10 years ago now. So where we had this leachate recirculation system, as you can see over here, they had this leachate recirculation going on, and from the leachate recirculation system, after there always as I said, you cannot do the leachate recirculation for a long period of time. So at some point of time you will start, or you can circulate part of the leachate, but part of the leachate has to be treated. So they had a leachate treatment plant where it was essentially a mixture of aeration pond, and they had some anaerobic like a pond as well, and then there was an aeration pond, so both anaerobic and aerobic. And after that there was a sand filter system that you can see over here. That system was sand filter system, which is it passes through a sand filter, essentially multimedia filter, and then it used to treat the leachate. And then once we have this treated leachate is sprayed fill in different zones. So you have this treated leachate which you spray fill around the landfill area. So this is that's one way of managing leachate as well, but this is a small landfill. This is not like a big regional landfill. So you see a close picture of anaerobic sand filters for leachate treatment. So these are the anaerobic sand filter. You see it's being aerated, and at the same time it is passing through this sand filter, and it's removing some of these contaminants, organic contaminants, which is present there. Okay, and then it is a spray. As you can see, it is sprayed around the landfill property. So that's the irrigation sprays done and along the landfill property for this leachate. Leachate storage tanks. This is how typical storage tanks looks like. Many times it has a double layer. So this is, you see, a outer layer, and then we have an inner layer just to prevent any leakage. So even if the inner layer gets broken for some reason, this outer layer will prevent the leachate from going out. So those are used as well. Leachate recirculation is also done using the spray irrigation. So this is on top of the landfill. As you can see, the garbage is there and the leachate is being sprayed around. So as you can see over here, the leachate is being sprayed around this system where it is being used as a spray irrigation to recirculate the leachate. So as you know, that for the recirculation of the leachate, the goal of this recirculation is to have this we do this leachate recirculation because to increase the moisture content. The goal is to increase the moisture content, as we have talked earlier. Why we want to increase the moisture content? Because increasing the moisture content makes the life of microbes comfortable, and then the microbes love that more moisture, and that it helps in degradation of the garbage. So here you saw that spray irrigation in the previous slide. This is how the leachate recirculation can be done on top of the landfill. This is another way where you have these trenches being laid. So you have these trenches in the garbage. So this is trenches in the garbage where we have laid this pipe. These pipes have actually perforations in there, and then we'll pump the leachate back into this system, and then the water will actually go out from side, and then it will try to distribute the moisture in this area. So we'll have one pipe here, another pipe could be somewhere here, another pipe could be somewhere here, and then we have to actually calculate the spacing of these pipes and what should be the diameter of this pipe, and those things will become part of the leachate recirculation system design. So those things but leachate recirculation is also done using this. What is known as this? These are known as horizontal trenches, and you can do it for vertical trenches as well. So in terms of the leachate treatment methods, we'll not go too much into those leachate recirculation system, because that's when we talk about bioreactor landfill in great detail, that's where we cover those aspects. But if you look at coming back to the basics, what we have started talking in this video, that once we collect the leachate, we have to treat it. So in terms of the treatment, there are different processes which can use. We can use physico-chemical process. So here are some examples of the physico-chemical process. You can use like adsorption, coagulation, flocculation, and as you read these processes, they seems to be very similar to what you have seen in a wastewater treatment plant. Some of these processes are also actually most of these processes are also used for water treatment plant. As you know, water treatment plant is mostly physical chemical. There is no usually there is no biological system in water treatment. Wastewater has both physical chemical and biological. So in terms of the physico-chemical, you can have adsorption, you can have coagulation, flocculation, chemical oxidation, air stripping, ion exchange, membrane filtration like reverse osmosis, nanofiltration, ultrafiltration. So those things are used. So the process, which process will work, it depends on the age of the landfill. Why? Because based on the age of the landfill, the leachate quality changes. As you saw earlier, based on in the previous video, based on the stages of decomposition, based on which stage the landfill is, the leachate quality changes. Similarly, based on the age of the landfill, there will be different processes that you would like to use. So in terms of this different physico-chemical process, we will try to compare which one will work good for what. So in terms of the landfill age, so if you look at the treatment process effectiveness based on landfill age, based on leachate type, if it's less than 5 years, we are mostly looking at it's a young leachate. We call it a young landfill. Less than 5 years is your young landfill. So it's for the most of these leachate, when we talk about this leachate, many biodegradable component there. If it's 5 to 10 years, it's called intermediate. So again, we have intermediate in terms of the biodegradable leachate type, and more than 10 years, it's a stabilized leachate. So less biodegradable organics. So in terms of the treatment efficiency for different types, in terms of biological treatment, since we have the biodegradable, it's good, and it's fair, and then it's poor because we don't have much biological degradation left. So biological treatment is not going to work. Adsorption, since you have things building up, initially you have the fair to poor, then you have good to fair, and this one is good because you have it's a matured, stabilized landfill. You can use the adsorption to whatever some of these contaminants there, it can absorb in those surfaces that is provided to us. Coagulation, flocculation, again, initially you don't have any of those like a colloidal particle in there, but it starts building up, and then it does build up. Chemical oxidation, because it's mostly biological treatment. If it's good for biological, you don't have to use chemical oxidation, but as you move, as you age, the landfill ages, it gets better. Membrane process, initially you don't need membrane processes, but as for the matured landfill, you start using this membrane process as well. So based on the age of the landfill, based on the type of the leachate, the treatment process effectiveness will change. But since we are talking about one landfill, we cannot really change, say if you start setting up this reverse osmosis in the beginning, so you cannot, what I'm saying is you cannot, you have to think about the leachate treatment system from the very beginning. Yes, you can add things as the landfill progresses, as the landfill ages, we can add things to the leachate treatment system. So what it says that initially we may not have to go for this membrane process. Initially we can go for a biological treatment first, and then as the landfill ages, we can think about adding some more stuff, because landfill will work for 30-35 years. So these because of the different cells in the landfill, there could be a cell which is already at this phase, and where at the same landfill site we'll have some cell which is at this phase. So we will have combination of all these different phases existing within the same landfill property. So we can have design the system in such a way so that we can make use of all these different treatment technologies based on, like, cell 1 is being treated by biological treatments, is being treated mostly by chemical oxidation and reverse osmosis and all those kind of stuff, while the cell 2, which is the brand new cell, which is a still young leachate, we can use the biological treatment more for that. So we can use different combinations, so that can be done in terms of the landfill treatment process. RO is used quite extensively these days, especially if you want to make water to be really clean, and that can be reused as a potable water. So you can have RO system is used for that. Then other thing is that we talked about the landfill leachate. Now the next big thing is landfill gas. So landfill gas is also it's important parameter. So as I said earlier, in terms of the landfill design, there are a lot of things that we need to worry about. We need to worry about the liner, we need to worry about the leachate collection system, we need to worry about the leachate treatment system, stormwater management system, groundwater management system, but one of the important components is also landfill gas management system, because landfill will produce gas. Ultimately, what is the goal of this environmental protection is to make sure the environmental, we should have less impact on environment. So this landfill gas, the methane gas which is released during the anaerobic decomposition of waste, it's a greenhouse gas. So we have to collect this landfill gas, which is predominantly methane and CO2, and then treat this gas and make, or if we cannot do anything with that, we can flare the gas to convert everything to CO2 to make it less harmful. So in terms of the landfill gas, we use gas wells are typically used. You install gas wells once the landfill has been filled up, and a vacuum is spooled on these wells. You apply vacuum to extract gas into the pipe system. The gas can be flared if you don't have the waste to energy, or it can be turned into energy. So it would be really nice to have a gas to energy system where if you produce enough gas. So again, when I'm saying if your landfill produces enough gas, that means that the gas quantity has to be significant. There is always an economy of a scale. We talked about that earlier in the thermal treatment too. There has to be an economy of a scale. If there should be sufficient gas. So that's why the concept of this regional landfills are coming up, because we are trying to go for a bigger landfill, and we use that for that. So in terms of the landfill gas, you have waste. When the waste degrades, so we have essentially methane and CO2 that is being produced. So those are the landfill gas that is produced from the degradation of waste. And there are other things in there too. We have methane and CO2. Those are the two major ones. But there are some water vapor. There is some hydrogen sulfide, which creates a smell, because methane doesn't have any smell. NMOCs, non-methane organic compounds, are there. There could be potentially some heavy metals, especially if you think about arsenic and mercury. You can see them. Arsenic is in a very reducing environment. Arsenic goes to ASH3, which is an arsine gas, and which is a garlic kind of smell gas, and that you can see over there. Mercury is in a sulfate reducing bacteria condition. Mercury have a tendency to convert to methyl mercury, and then methyl mercury goes into it's a volatile, so it can go into the gaseous form. But there are some other gases in here, especially sulfur based gases. The sulfur based gases is the one which causes a lot of smell. One gas which is called mercaptan, MERCAPTAN, I think, which is the most nasty one, which smells a lot. So those are those are the ones which are of concern in terms of the landfill gas. So why bother with the landfill gas? The smell we talked about, it's a toxic. Hydrogen sulfide, as you know, it's a toxic gas. It's a greenhouse gas. It's an explosive gas. So all those things that is because we have to bother. So those are the reason why we need to bother with this landfill gas. And then it's a potential energy source. So landfill gas is a potential energy source. It can be used for energy generation. So that's important as well. So how is the gas collected? We typically use vertical well to collect the gas. So we will have the vertical wells, and we apply vacuum. So we install it's after the landfill has reached a certain grade, after have reached the height, and then we use an auger to drill the hole, which I'll show you. So this is a typical landfill cross section. So you have this vertical gas well. So you have this is your vertical gas well. Similarly, you have the other wells, and we are looking at a cross section. So we'll have several wells on top of the landfill. So that's your That's a typical gas well, how it looks like. We have used an auger to drill a hole, and this has some drainage material. It could be crushed glass, crushed wood chips, or like a truss tires or anything which can go there. And then you have this landfill gas pipe, which is the perforated pipe. And so what we do is we apply vacuum. We are applying vacuum. So vacuum is pulling the gas. So all the gas is moving in here. So it is actually going into the system, getting into these pipes, and then it comes up. And this is your head. You can have a header pipe in there, which will collect to all these gas pipes, and then the gas will go into this header pipe, will be taken to the either flare station or landfill gas to energy place. So gas, you will have several wells, like here there is a well here. We also have a well on the side slope, and then we can also, even in the leachate wet well, sometimes you will have the gas there. So leachate, it also does make way to the leachate collection pipe. So landfill gas actually try to move wherever it can find the least pressure. So as you know, the gas travels in the path of least resistance. So wherever it can find least resistance, it will try to move into that particular area. So these are called horizontal gas collection well, this on the inclined side, and these are called the vertical gas collection wells. So that's and then we don't want to go too deep here, because if we don't want to put a pinch in the liner, so we want to don't go too deep, but we're still deep enough for a good collection of gas. So wells, the wells could be a passive well, which is well open to atmosphere. Usually that used to happen in a smaller landfill, where you just put some well up there so that the gas can escape, because we have to let the gas escape, otherwise the methane may catch fire and then the whole landfill will be on fire. So but that was just an escape, but you are losing all the gas. You're not really collecting the gas, you're not treating the gas, you're not using the gas for any purposes. But that's kind of the thing of the past. You don't see passive wells in big landfills today. So what you see is actually active wells, which is connected to a gas extraction system. So it's a gas extraction system we are using, and so the active wells are used for that. So this is another sketch for that. So this is your like gravel pack. Sorry, you can use the gravel pack, or you can use something other like a wood chips and those things as well. But that's your gravel pack in here, and then in the middle you have this perforations, and you have this pipe up to this point, and then here you put some seal. So these are the seals using bentonite clay or something like that, so that when you apply vacuum, you are not actually sucking from the outside as well. So you put a seal in here so that the most of whatever is the gas will try to go from this side. And then you have a perforated PVC pipe, that's a wellhead. You have a gas extraction pipe, it's connected to the main header pipe, and that takes it to for this one, that main header pipe, and that will take it for to the flare station or for landfill gas to energy system. So what is the driving force for the gas? It's the pressure. Without any well, what will happen? The gas will try to find the surface or the bottom. So if you don't provide any well, the gas will just try to travel and go to wherever the path of least resistance, and it ultimately may reach the top. Or if it's towards the bottom layer of the waste, it will try to go into the bottom, into the leachate collection system. So what does the well does? Wells actually, these gas wells provide the path of escape. They create a pressure gradient. So the gas travels in that particular path and gets collected. Gas collection system, actually, it's since the landfill, most of the landfills are so huge, so gas collection system efficiency is a bit low. We do lose a lot of gas. They are called fugitive emissions. So when sometimes we have like around 65 to 70% gas collection is considered a very good gas collection system, because there is a lot of fugitive emissions happening from the landfill sites. So like what is the landfill gas is typically extracted to a blower or flare station. So these are your landfill, these are the gas wells as you saw earlier. So if these are the gas wells, and then it's all gets connected to this header pipe. The header pipe is taking it to the flare station. Before it gets flared station, since this gas is a little bit moist, a little bit warm, when it comes out in the ambient temperature, it tries to cool down. So you will have condensation happening, and as part of the condensation, you will have what is known as condensate. So this condensate, since this water, very low pH, we need to remove this condensate before it goes to the blower flare station. So that's one of the important aspect of landfill gas collection system as well, because we tend to forget that there has to be a condensate removal. So in terms of landfill gas generation, how the landfill gas will be generated over time, it's if it's a dry tomb landfill, the waste does not have any recirculation going, the moisture movement is not very good inside the landfill, the gas production will be over a very long period of time. So as you can see on this sketch over here, we have presented three scenarios, which has one is with a half-life of 20 years, and then 3.668 and 1.35 years. 20 years means it's a kind of dry tomb kind of situation. It will say half-life, as you probably I assume that you know what is in half-life. Say if you start with 100 kg of certain biodegradable waste, after how much years it will be 50 kg. So how much time it will require to degrade 50%. So that's the half-life. So half-life of 20 years means if you have 100 kg of just biodegradable fraction organic waste, it will take 20 years to degrade to up to 50 kg, and then another 20 years to come down to 25 kg, and then 12.5 kg. So it will take a long time to degrade. So if we can somehow change that degradation, if we can make the waste degrade faster using it as a bioreactor landfill, reducing the half-life to 3.68 years or 1.35 years, we see that the gas production it happens over a smaller period of time. Here for all these three sketches, like whether this one or this one or this one, if you do the area under the curve is what gives you the total gas that is being produced, and it should be the same. Say if you have a certain mass of garbage, if you have say 1 kg of garbage, and it's the same garbage, and then it is being degraded in a dry tomb over 20 years or more, in another system, in a recirculation kind of system where you have half-life of 3.68 or another half-life of 1.35 years. So that since these numbers tell me the rate of reaction. The smaller the half-life, quicker is the rate of reaction. But the amount of garbage amount of gas that particular waste can produce is the same. So if you take the area under the curve for these three graphs, the area under the curve will be the same. It's the total amount of gas that will be produced in that landfill. It's only the time period changes, like how you make half-life smaller and smaller, like more and more faster and faster degradation happening there. So, and the condensate is the moisture that condenses from the landfill gas when it cools down. We already talked about that. So, and then it has to go to flare station or to a landfill gas to energy. So with that, let's kind of conclude this particular video where we talked about essentially about some of the leachate treatment techniques, and we also looked into the landfill gas, some of the basics of landfill gas, how the landfill gas collection system works. We talked about that. Then I'll talk a little bit more in detail about the bioreactor landfill. We'll spend some time in the next video on bioreactor, and then we'll talk about some other aspect. So with that, let's close this video. I hope that you're enjoying this course, the videos, and if you have any question, feel free to put it on the discussion board. We are trying to keep up with that. We are trying to answering those discussion board very quickly, at least within 24 hours. That's our goal. So let's keep that active, and that's the only place, where we communicate. We are communicating mostly through the discussion board. We are not like any WhatsApp group or other things in there. So okay, so that's it, and I'll see you again in the next video.